The purpose of this video is to show you how to carry out an independent samples t-test in a way that actually exactly matches how you'll have to do it in, for example, your SPSS worksheet and the midterm. So you can see over here, start by testing whether men and women are different in self-esteem. All right. This is typical of what you're going to find in assignments and on the midterm. You'll have basic instructions and then you'll have specific questions in Canvas that you will have to answer. All right. So first of all, you have to think about actually what it means. Now here it's always extremely important to make sure you understand the data set. So that will be your first step. Okay. And then you have to understand the question. Start by testing whether men and women differ in self-esteem. Is this a one-tailed or two-tailed test? So whenever it says if something differs, it's going to be a two-tailed test. If the question is do they differ, are they different, right? Without specifying that you expect one to have higher scores than the other, this is always going to be a two-tailed test. Okay, that went a little bit crazy. All right, so here we are going to have a two-tailed test. Next, it says write out the statistical hypotheses. Now, if you go to the statistical decision-making process help page, it will give you exactly the limited options for what the correct question answer to this question is going to be. For here, I'm just going to show you an example of what it's going to be. All right, so let me get Canvas pulled up so you can actually see what this would look like in Canvas. All right, so let me pull this over here. We're going to use this to show the example. Notice that it says state the statistical hypotheses using plain English and statistical notation. So for our example, the question was, would men and women differ in self-esteem? So it's going to be a two-tailed test, right? So you could click on this and find instructions if you're on your own. Here I'm going to show you. So first you click on this radical X sign. In this you're going to do H, that's for hypothesis. Click on this little subscript, 0. We're going to start with the null hypothesis. After we do this, we need to click the right arrow on our keyboard to get out of the subscript. Put a colon, 2 dots, right? Here, because it's two-tailed, the idea is that mean 1 minus mean 2 will be equal to 0. There's no difference. So we go to Greek, mu, subscript 1, right arrow to get out of the subscript, minus mu, subscript 2, right arrow to get out of it, equal, just use your keyboard, 0. That's your null. There's no differences between the mean. Remember, a null hypothesis always has an equal sign in it. Next, we'll do our alternative hypothesis. H, subscript 1, or A is correct, right arrow, colon, the same thing we did before, mu, subscript 1, right arrow, minus, mu, subscript 2, right arrow. Now we're going to need to go to relationships and select not equal to 0. Hit done. Here we have our statistical hypotheses. In plain English, we would have to say something along the lines in men and women will score differently in self-esteem. That will be our research hypothesis. They will be different. The null hypothesis will men and women will not differ in self-esteem. Right? That's all there is to it. Okay. Now that we've understood what we're going to do, we're going to use SPSS to actually test this hypothesis. we will select Analyze. First, we're going to make sure how sex is coded, right? So 1 is male, 2 is female. Okay. Now Analyze, Compare Means and Proportions, Independent Sample t-test. We're going to put, let's reset this. We're going to put sex in the grouping variable place. That's where the categorical variable is. Hit Define Groups and select Continue because default is 1 and 2. Next, we're going to put self-esteem in the test variable field. Then we hit OK. All right, so here is the output. It tells us up at the top there were 48 males that a mean self-esteem is 40.06. Standard deviation is 6.12. 154 females with mean self-esteem is 37.53. So just looking at the means, it looks like in this sample anyway, males self-reported greater self-esteem. Next, we're going to look at this second table. We're going to ignore this part here. Ignore this. Then we're going to look at the top row. So the top row. Okay. Now we're going to look at, we see there's a difference. We can look at the two-sided p-value because it's a two-tailed test. We can see right here that the p is p equal 0.0, that's a 0, 1, 9. Is this less than 0.05? Well, yes. If you're struggling to compare it, you can think, is 5 cents greater than 1.9 cents? And you can think yes, right? So we can reject the null. When p is less than alpha, in this case 0.05, we reject the null and conclude there is a difference between the means. Okay, so let's go over and look at our questions here, right? First, what is t obtained observed? That is this value right here. T equals 2.36. So you could put here 2.36. What is the p-value? Here it's a non-directional two-sided test. It's 0.019. 0.019, right? Our effect size is Cohen's d. It's right here under the point estimate. It is 0.39. 0.39. Next question, who reported greater self-esteem, males or females? We already looked at that and saw that males with a mean of 40.06 reported higher self-esteem than females did, right? So here the answer would be males. Finally, what is your statistical decision at alpha equals 0.05? Here, because p is less than 0.05, we're going to reject the null hypothesis. Your statistical decision has two options. Either you reject the null hypothesis or you fail to reject. Here, because p is less than 0.05 or less than alpha, we reject the null. Okay, so now we have to summarize the results in plain English, which, as you should know by now, is the most difficult part. But it's actually pretty easy. This just means use no statistical jargon and tell a person who knows nothing about statistics what the result of this analysis was. In this case, it's simple. Males have greater self-esteem than females. And that's it.